Hello everyone, once again welcome to our physics class. So as discussed in our first session, I had told you in this session we will discuss about optical instruments. Our human eye is the most important optical instrument. But as a part of the deletion, human eye has been deleted from our syllabus and we need to study about other optical instruments like microscopes and telescopes. So let's get started with microscope today. Children, so let's discuss the magnification of a lens first. So magnification denotes how much the image is bigger or smaller with respect to object. Okay, so the image produced by a lens can be enlarged one and the image produced by a lens can be a diminished one. But if we want to calculate how much bigger or how much smaller an image is with respect to the object, we need to calculate magnification. The magnification is defined as the ratio of height of image to height of object. So this is the equation to find out magnification. Magnification M. Magnification is denoted by small m. Small m is equal to height of image by height of object. Also, one more formula is there for magnification. Magnification M is equal to V by U, where V is the distance of image from the lens and U is the distance between object and the lens. And you know, lots of informations are available from the value of magnification. So, if magnification is equal to 1, it means height of image is equal to height of object. Okay, and if magnification value is greater than 1, it means height of image is greater than height of object. That means image will be an enlarged one. If magnification is less than 1, then height of image is less than height of object. That is, image will be a diminished one. Also, if magnification is positive, then it will be a real image. If magnification is negative, if magnification is negative, it will be a real image. And if magnification is positive, it will be a virtual image. Okay, so such informations are available from the value of magnification. So for example, if magnification produced by a lens is minus 0.5, what is the nature of image? So first look at the sign, it is negative. So the negative sign implies that image is real. And then look at the magnitude. Magnitude is 0.5, which is less than 1. So if magnification is less than 1, then height of image is less than height of object. That is, it will be a diminished image. So it will be a real, inverted and diminished image. So if an image is real, it will be inverted. If an image is virtual, it will be erect. Okay. So that's all about magnification. And next we can discuss about power of a lens. So what do you mean by power? Power is the reciprocal of focal length. And the focal length is expressed in meter. So the amount of or the extent of convergence or divergence of a lens is indicated by power. So power is defined as the ability of a lens to converge or diverge a light ray. It is defined as the reciprocal of the focal length of a lens. Power P is equal to 1 by focal length, and that focal length should be expressed in meter. If we substitute the value of focal length in centimeter, you will not be able to calculate the actual or the exact value of the power of a lens. Then SI unit of power is diopter and it is denoted by capital D. I had already learned about this concepts in your class 10 physics. Okay. Next, we are going to derive the focal length and power for a combination of two thin lenses in contact. So for that, we need to consider two thin lenses as shown here. Okay, so this is first lens and this is our second lens. Both the lenses are thin. So two thin lenses in contact. Okay, so here O is the object. Light ray from the object goes through the first lens, undergo refraction, then goes through the second lens, and finally in the absence of this lens, the image produced by the first lens might have produced here, but due to the presence of the second lens, the final image is produced here. Okay, so for the first lens, O is the object, I1 is the image. But for the second lens, I1 is the object and I is the image. Just like the assumption we did for lens maker's formula. Okay children, so once again I repeat the concept. For the first lens, O is the object, I1 is the image. For the second lens, I1 is the object and I is the image. So here I1 acts like a virtual object for the second lens and final image is produced here. Okay, then the distance between object and this lens will be, this combination will be U. Distance between image and this combination is V, and distance between image I1 and the combination is V1. So first we are considering, since it is a thin lens, here we can use thin lens formula. And which is our thin lens formula? 1 by V minus 1 by U is equal to 1 by F. This is the thin lens formula, and since the lenses in contact or the combination of lenses are thin lens, so we can calculate or we can apply this thin lens formula, 1 by V minus 1 by U equal to 1 by F. Now for the first lens, what will be this V, U and F? Okay, so for the first lens, O is the object and the object distance is U. So object distance U will be U itself. For the first lens, I1 is the image. So the image distance will be V1. So V, image distance V will be V1. And focal length. For the first lens, the focal length will be F1. Similarly, for the second lens, focal length will be F2. Okay, now substitute all these assumptions in our thin lens formula. So what is thin lens formula? 1 by V minus 1 by U equal to 1 by F. So for the first lens, V is V1. So instead of 1 by V, we can write 1 by V1 minus 1 by U is U itself equal to 1 by F1. So this is our first equation. Similarly, for second lens, apply the thin lens formula. For second lens, I1 is the object. So the object distance U will be distance from I1 to the combination, that is V1. And for the second lens, I is the image. So image distance will be V. So V, image distance V will be V itself. Then for the second lens, focal length is F2. Okay. So what will be the thin lens formula? It will be 1 by V minus 1 by U. Instead of U, we can substitute V1 equal to 1 by F2. So this is our second equation. So these are the two equations, and we are doing some mathematical operations on these two equations in order to get an expression for the focal length and power of this combination. So here this was our first expression, 1 by V1 minus 1 by U is equal to 1 by F1, and this is our second expression, 1 by V minus 1 by V1 equal to 1 by F2. Now just add these two equations, equation 1 plus 2. First add the LHS part. So we will get 1 by V1 minus 1 by U plus 1 by V minus 1 by V1 equal to 1 by F1 plus 1 by F2. Now here we have plus 1 by V1 minus 1 by V1, it will cancel. Then what is left? We are left with 1 by V minus 1 by U equal to 1 by F1 plus 1 by F2. Now if we replace the two thin lens with a single lens such that the image is produced at the same position for the same position of the object. Okay, see children, this was our combination, and if we replace this two lens with a single lens such that the image is produced at the same position for the same object position, okay, without any change in u and v. If image is to be produced at the same distance for the same object distance, then 1 by v minus 1 by u is equal to 1 by f. Okay, where f is the focal length of that single lens that replaced the two thin lens. Okay, so let this be our equation number 4. And here there won't be any change in v and u, because using that single lens, we assume that the image is produced at the same position as that in the previous case and for the same object distance. So v and u will remain the same. So the LHS of these two equations 3 and 4 are equal. So we can equate the RHS part, and when you equate the RHS part, you will get 1 by f is equal to 1 by f1 plus 1 by f2. So here f is the focal length of that single lens, and f1 and f2 are the focal lengths of the thin lenses in contact. So this is the focal length, or this is the expression to find out focal length for the combination. So 1 by f is equal to 1 by f1 plus 1 by f2. Suppose there are three lenses in contact, then 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3, like this. Suppose there are n number of thin lenses, then this can be written as 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3 plus etc. plus 1 by fn. Okay, now you know 1 by f is the expression for power. So power of the combination is equal to 1 by f1, that means power of the first lens, plus 1 by f2, power of the second lens, like that. So this is the equation to find out power of the combination of thin lens. Okay, and if there are n number of lenses in contact, then power p is equal to p1 plus p2 plus etc. plus pn. So this is the expression to find out power of a combination of n number of lenses. Then what will be the magnification? Then total magnification of the system or of the combination will be m1 into m2, where m1 and m2 are the magnification produced by first and the second lens respectively. So don't add the magnification value. If you want to get the total magnification of the combination, multiply the magnification produced by the individual lenses. So these are the expressions to find out the focal length, power and magnification of the combination of thin lens. Okay children. So that's all about the thin lens. So with this I am concluding this session. Notes of the topic have been uploaded. Just go through it. We will meet in the next session. Till then, take care. Stay home, stay safe. Thank you.